Okay, I'm going to try to go through this fairly quickly. But this is the lesson that we did today in class, Wednesday, September 11th. We talked about direct variation. Okay, so direct variation is a linear function, which is a line, that goes through the origin. That is the main concept of direct variation. So if these are all different lines, and it says which lines are direct variation. So that would be this one right here, and this one right here. And the reason, and now that I've done that, you can't even tell. The reason why those are, let me just draw arrows, this one and this one, is because they both go through the origin. Okay? So if they go through the origin and they are a line, so they're a line and they go through the origin, it's a direct variation. Now remember, last year you talked about y equals mx plus b, the slope-intercept form, which is the equation of a line. Well, if a direct variation does not have a y-intercept, then it does not have a b value. Okay? So when we look at an equation, we can tell if it's a direct variation if it's written in this form. So if you go to the next box, you have all these different equations, and we're not going to match them. We're just going to go through and figure out which ones are the direct variation. And so we want it to match the y equals mx. So this is y equals mx plus b. So this is not a direct variation because it has that minus 5. This is a y equals mx. So this is a direct variation. This is y equals mx. So this is a direct variation. And this is y equals 1/3 x mx plus b. It has that b, so this is not. Okay? So the one thing that you need to remember about graphs and equations is if it goes through the origin and is a line, then it's a direct variation. And when you're looking at the equation, as long as it doesn't have this plus b at the end, then it's a direct variation. Okay? All right. The last thing is to be able to tell on a graph, or sorry, a table, if it's a direct variation. So there's two things. One, we want to know if it goes through the origin. Okay, so does it go through the origin? And two, we want to know, does it make a line? Okay, and I'm going to put K, because that's what we're going to have to find. Now you're saying, what is K? K is just the slope, the m. So right here, when we say y equals mx, that's the same thing as y equals kx. K is our constant of proportionality. If it's a direct variation, then it has a constant of proportionality, and it's really just the slope. All right, so if we look at the first table, it has 0, 0 in the table. So it does go through the origin, so we can check that off. And then the second thing we need to check is we need to find k. Well, if we rearrange this, we can tell what k equals. And k equals y divided by x. Okay. Now remember, yesterday we talked about that constant, the change in y over the change in x. That's the slope. That's that rate of change. And so here, k is just the y divided by the x. So we're going to go through and divide these. So this is -1 divided by -2. This, I'm not going to divide those because you can't divide by 0. 1 divided by 2, and then 2 divided by 4. And when we check all of those by plugging them in the calculator, let me show you how to do that. Find my calculator. Alright, so to do that, we're going to type in -1 divided by -2, and then hit math, enter, enter, and it makes a fraction for us. There it is, 1/2. Okay, and then we can do, so this one equals 1/2, this one equals 1/2, and that one equals 1/2. So they all equal 1/2. Okay, so it is a direct variation, so we would say yes, and k equals 1/2. All right. So over here, if we go through and check to see if it's a direct variation, it has to go through 0, 0. 0, 0 needs to be paired up. It is not. So for that reason, it's no, and I don't need to do anything else. Okay, that's the easiest way to check, is if it goes through 0, 0. Now, if you want to go through and divide these, you can probably do that in your head and see that they don't equal the same thing. So that's another reason. All right, the last table, you don't have 0, 0. You don't see it, okay? But that doesn't mean that it doesn't exist. And so when we look at this table, we're just looking at a portion of it. And we know that it goes this way and it goes backwards. So we've got to find where 0, 0 would be. Well, these numbers are going up by 2. So if I go backwards by 2, my next number back is 0. And then these go up by 1, and my next number back is also 0. So it does go through the origin. So it goes through 0, 0. So we can check that off. Now we need to find this k. And to find k, we're just going to divide these. So we're going to say 1 divided by 2, 2 divided by 4, 3 divided by 6, and 4 divided by 8. And all of these equal 1/2. So since they all equal 1/2, that's your k. So k equals 1/2, and yes, this is a direct variation. Now, if you want to write the equation, all you have to have is k, and we can just plug it in. So the equation for this could be y equals 1/2 x. All right, and I'm going to skip this, and we'll just look at this one before we go to the back. All right, so it says that the slope of a direct variation is referred to as k, which we talked about that. The equation is y equals kx. All right, so let's see if this is a direct variation. So if we follow our pattern, it's going up by 2, so we go backwards by 2, we get 0. This one's going up by 5, we go backwards by 5, we get 0. So it does go through the origin. Okay, and now we're going to divide these. So y divided by x, y divided by x, y divided by x, y divided by x. And all of these equal 5 over 2. So yes, it's a direct variation. This is our k, and it says to write the equation, and it's just y equals 5 over 2x. Okay, so quick review. If it's a graph, it's going to be a line, and it goes through the origin. If it's an equation, it's just going to be y equals kx. You're not going to have that plus b. If you have a table, you've got to have an origin. The origin, it's got to go through the origin in your table, and it may not be in the table that you see it. You may have to move around backwards. And they all have to have the same k value. So if you divide your y and your x and get the same number, that is your k. All right, and then the next video will be the back.